Hello, welcome back. My name is Ambeni, and today we are going to see facts and dimensions. Alright, now, without wasting time, let's just dive right into business itself. And we start by asking, let's just be curious, what is facts and what is dimension? Now, in this module, we're going to see dimensions and fact tables. So it's just very short module, and I promise you at the end of this module you'll have clear understanding of what dimension is and what fact table is. Now let's just start. What is dimension? Dimension is just simply a structure that organizes facts and measures. But hold on, you may be asking, what is facts and what is measure? Just cool down. We're going to see it as we are moving. It's just in a couple of slides. In the next couple of slides we're going to see that. But now let's understand what dimension is. And I write there, as you can see, the definition of that dimension. I said it's a collection or references or descriptive information about a variable event, about a measurable event, sorry. So the collection of that kind of collection or references about an information that can be measured is called dimension. But in a simple way, it's just a structure that categorizes measures and facts. Now, in order to enable a user to answer the business question, we need to have dimension. Now, let's see the examples of dimension. Product is dimension. Time is dimension. Geography is dimension. We're going to see it in the next couple of slides, the real examples of dimension. But keep in mind now, if you see time in a table, that is dimension. Product is dimension and geography is dimension. So keep in mind that dimension is simply a structure, nothing fancy. It's just a structure that organizes the facts and the measures. Now, what is facts? Facts is simply a numerical value that have impact on the business. And the good examples of fact is sales, profit, quantity, and discount. So in a very short definition, you can say measure is aggregation of facts or tables, the aggregation of facts or dimension. Now, for example, sum of sales, that is fact or measure. We are measuring the sum of sales. Now, average of profit, see that? So that's the measure. Count of items, count of customers. How many customers do I have? How many items do I have? What is the average of profit last month? How many sales I have in last month or last week, and how will sales be in the next month? So that's the measure. So let's just move quick one step back, and let's see now again the definition of dimension. We say dimension is a structure that categorize, keep this in mind, that categorize what here? That categorize facts and measures. It categorizes facts and measures. So the aim of dimension is to enable the user to answer the business question. What kind of business question is that? It's like this. How many sales I have? What is the average profit? See? Count of items and count of customers. So, in summary, fact, it is a numerical value which have impact on business. Now let's move on. Let's have a look at this table as an example. So we have this table, and it's model, make, year, and this I think is a kind of serial number. So this is car table, which consists names of car, model of car. We have Toyota, Honda, and who make it, like that, Sona, IST, and that, and the year, like this one. And then we have sales, profit, quantity, customer, product, and store. Now the question is, which one is fact and which one is dimension. As I said, sales are dimension. I mean, sales are facts. These are measures. Profits, it is a measure. It's a measure. It's a fact. Quantity. See that the point. So that's just a simple example. So keep in mind, fact is the numerical value that have impact on the business. Now, dimension table mainly consists of descriptive attributes that are contextual field. Now let's move one step back again. Keep that in mind. Dimension table simply consists of descriptive attributes. Right here. This is dimension table. This table here, you can see it has only the descriptive attributes. Model, Toyota, see who make it, IST, and the year, where I think the year they released this. So that's it. So dimension table simply consists of attributes. I mean the descriptive attribute. Yeah. So it consists of descriptive attributes like this. Now, and also dimension tables provide a descriptive or contextual information about the measures of fact table. So it's like a more information about fact table. We're going to see it in the next couple of slides. You can see that fact table consists of foreign keys, which are primary key of dimensional table. So in general, dimension table provide more information about fact table. So a dimension table consists of surrogate keys, natural key, and set of attributes. So dimension table are also called reference tables. We're going to see it why we are saying it is a reference table. But let's just show you an example here. Let's see, for example, let's say we have this table. I'm going to draw it right quick here. I have this table, and I also have this table here. Sorry, I'm not really good at drawing and I'm using mouse, so just be patient. So we have this table here, and I'm going to divide it in the same way like this. So this table have an ID. Let's call it an ID, and then let's say call this one is a dimension table, and this is a fact table. So what we do, we take this ID here, right here, and we put it here, right here. And then this one becomes the foreign key, which is the primary key of this table. So that's the key point. And then, so we have these tables have relation. So if we want to find more information about this dimension table, we use this foreign key from this fact table and move to this table. So that's the key point. And that's why we say dimension tables are also called reference tables. These dimension tables are also called the reference table. We refer from fact table to this dimension table to get more information about this foreign key. So I think you're getting my point. And that's why this point also says it provides a descriptive or contextual information for the measurement of fact table. For the measurement of what? Fact table. So don't worry if you don't really understand clearly here. We're going to see it as we are moving. We're going to understand it very well as we are moving. Alright. Now, that's dimension table. How about fact table? What does it have? Now, fact table consists of business facts and foreign, and yeah, it consists of business facts. I wonder, I think this is foreign key. Let's just real quick, I'm gonna foreign key here. Sorry. Okay, let's just move. Fact table mainly consists of business fact. That's the key point. And the foreign key, yeah, it is a foreign key. So it consists of foreign key that refer to a primary key in the dimension table, as I shown you in this example here. This, it is a foreign key which reference what? This table, dimension table. And that's this point, what it's saying here. As you can see, this point here, it says the fact table mainly consists of business facts. Sorry, business facts. I'm gonna clean up this right here. So it consists of business fact here and the foreign key that refers to primary key in the dimension table. So that's the point. And also fact tables provides the measures of enterprise. Yes, it provides the measures of enterprise. Okay, so let's move to the third point. Fact table contains a foreign key, measures, and a degenerated dimension. Now this point is very important here. This one is very important. It consists, what we have in fact table, it's foreign keys, measurements, and degenerated dimension. We're going to see it in just next slide here. Now, a fact table normally contains two columns. That's it. It contains two columns, as I've shown you. It contains these two columns here, and then column, and I think let's see. It contains of two columns. One that contains the facts, and another that contains the foreign key of the dimension table. Let's just draw. It contains two columns here, right? And then one column contains facts here, facts. Say we put those facts here, and then another one contains the foreign keys of the dimension table, like that. Now here, right here, that's an example. This at the very center, right here, this one is what we call fact table. And what did we say? Fact table contains the foreign key of dimension tables. Now let's have a look. We have this foreign key 1, and it is date key. So we are expecting, if we go to dimension right here, we will find date key as a primary key, and yes, it is right here. So this is the relation I'm talking about. This is the primary key in dimension table, but it is a foreign key in fact cell table. So we take this one and put it right here. Okay. Now the same for customers. You can see it's a primary key here, but we put it here into the fact sales. The same thing for product. We have here product, and we put it here. So this is a primary key, but right here it is a foreign key. And finally, for store key, we put it here. Just keep in mind, these arrows, we've laid all this, clean it right here, perfect. These arrows are drawn from fact to dimension. These are, see? We are drawing it from fact to dimension, from facts to dimension, fact to dimension, fact to dimension. Never draw it like this. No, that's not good. We draw it from fact to dimension. Okay, let's clean it up. Good. And now let's move. Now, data warehouse schema. Why do we want to learn data warehouse schema? We just see fact and dimension tables. But wait, where does this come from? Data warehouse. Data warehouse is just a collection of heterogeneous data. Multiple data sources are collected together for the aim of making decision and for making analysis, finding pattern from data. So we put those data together. It's just a warehouse. It's just a store of previous data. You can say data that have already been collected. We just store it there, but we store it there so that we can use it for finding for making maybe decision. That's the key point. Now, the main aim of learning these dimension tables and fact tables is because we are going to use this in a schemas, in a data warehouse schema. Now let's just see how we're going to use this fact table and dimension tables in a data warehouse schema. But what is schema itself? Schema is nothing really special. It's just a logical arrangement of entire database. So don't start to freak out and say, what is schema, by the way? Schema is just a logical arrangement. Keep that in mind. It is what? Logical arrangement of entire database. Now, mostly schemas consist of this one. Schema consists of tables, views, indices, and synonyms. So these are the four major, what you can say, for four major properties. I don't know also, but these things should be in a schema. And what schema is just a logical arrangement of entire database. Now we have types of schema: star schema, snowflake schema, and fact constellation schema. So these are very simple and easy. Star schema, as its name suggests, star. It's a schema that resembles to star. That's it. Snowflake schema is just a schema. I mean, it is an extension of star schema. It's a normalized star schema. In fact, fact constellation is sometimes called galaxy schema because it is a collection of star schema. So all of these two remaining schemas comes from here, from this star schema. And this snowflake schema is just division, multiple division of this one. And constellation schema, it's a collection of star schema. Now let's see it. Star schema is a relational database schema representing a multidimensional data. Okay. Now, star schema is also known as a star schema as its structure resembles to star. I said it. At the very center of star schema consists of fact table, and it's point toward to the dimension table. Let's see right here. This is the star schema. At the center we have fact table. As we said before, these dimensional tables have primary keys, and all primary keys of this table should be foreign keys here. Should be the foreign keys in this table, right here. So hence the name star schema. So this is an example of star schema. You can see it looks like a star. Dimension tables, dimension tables, dimension tables, dimension tables, like that. And right here we have the fact table at the very center. What I didn't told you before is after this primary keys to be here and becomes foreign key, you can see we have these two units here: units sold and revenue. What these are, they are just measures, facts, and this shows, this have an impact on the business, as we say that facts or measure is a numerical value that have impact on business. And we say, for example, we want to know, let me give you an example. We want to know how many items we sold in the last month. So in the last month, it's the time. So time, it's a measure. Keep that in mind. It's a fact. But how many units we sold, those units, it's a measure. And if you want to get that, for example, the units we sold, let's say product unit we sold. So we have relation here and here, and you can see that we have product ID here, and it's right, it should be here. I think we didn't put it right here. Anyway, let's use dealer. We have this dealer ID, and it's here. So if we want to access any kind of information from dealer, we take and we want to measure some kind of information in this dimension table, which is dealer. We measure it by using this dimension ID. So that's the key point. Okay, now let's see advantage of star schema. Star schema is very simple to implement, is it? Yeah, it's easy to implement. Simple forms of queries are used in using very simple queries. It optimizes database navigation. So you can read it more on your own. That's the advantage of star schema. Snowflake schema, as I said, is an extension of star schema. It adds additional dimension to the dimension table. Its shape resembles to snowflakes right here. So it's same like a star schema. We have this dimension, and at the very center we have a fact table. But what's different is that these dimensions get divided into more dimensions for the aim of normalizing these tables. That's it. That's the major difference between star schema and snowflake schema. So we are dividing dimensions into sub-dimensions for the aim of normalizing. You can see we divide this one, we divide into these two. So now let's move. It's an example of it. We are dividing. We have fact cell here, and this and this and this, but we divide this dimension here into this dimension, and we divide this one into this dimension. So it's kind of normalizing these dimensional tables. Okay, the advantage of this one is pretty obvious now, because one advantage here is that it it consists of normalized data. It reduces redundancy. There's no repetition of data. Easy to update because we don't have a repetition of data because we normalized it. So that's the advantage of Snowflake schema. So finally, we have constellation schema or galaxy schema. And it's very simple because this one is just collection of star schema, as we can see here. The major difference between galaxy schema and the star schema is that galaxy schema have two fact tables here and here. It has two fact tables, but star schema have only one fact table, as you can see. So we can say this one, I'm gonna draw right here, as you can see here, like draw this. This one will be a star schema, and next, this again to this side will be another star schema. So you can see here, you can see it. We divided into two parts, and we have this star in this box, and we have this star in this box, and now they are combined together to form what we called it as a galaxy schema. That's it. It's viewed as a collection of star, hence the name. So this is an example of star schema. Constellation schema or galaxy schema. So now let's see the advantage of that. The different fact tables are explicitly assigned to dimensions. Where does this point lies? The different fact tables, we have this shipping fact table here, and we have this sales fact table here. So the different fact tables, you can see sales fact table and shipping fact tables are two different fact tables. But different fact tables can be assigned to dimension. Here, we assign it to this dimension, though this fact table has no relation at all with this one. But different fact tables can be assigned to dimension. So that's the point I'm talking about. Okay, and also it provides flexible schema. Yeah, can easily be changed. It's flexible, not fixed. And it's a simple assignment if you can do on your own to sharpen your knowledge more about, about this module. So you go and design data warehouse for sales, medical store, hospital system, pharmacy system, university system, hostel system, library, HR, and real estate system. So that's all about you. If you want to really try and sharpen your knowledge more about what we learn, that's all. Good luck. Have a nice time. See you in the next coming lesson. Goodbye. Don't forget to subscribe, please. If you don't really understand some concept, put your comment down. I will be responding very quick. Thank you.